So today we have an interesting geometrical problem. The diagram is on the screen with all the given details. Now the question over here is to find the radius of this circle using the arrangement of this diagram and the given data. So this is Anmol Mishra, and now let us see the solution. How can we find the radius of this circle? So first thing first, I am going to present two ways to solve this problem. So let us see the method number 1 first of all. So in the method 1, what we will do is I will simply draw the radius to these tangent points, and as these points are tangent points, the angle over there would be 90 degrees. Okay. Now what I will do is I will draw a line segment joining the points O and C. Okay. Now the question over here is to find the radius of this circle. So let it be equals to a variable x. Therefore OP is the radius, hence having a value x. OQ is also the radius, hence it would also have a value x. Okay. Now we can see that these two triangles are congruent to each other because of right angle, common hypotenuse, and these two sides are ultimately the radius. Hence these two triangles are congruent by right angle, hypotenuse side. So once two triangles are congruent, rest of the things between them become equal. So ultimately this angle and that angle become equal, and let it be equals to a variable alpha. And similarly the length of OC would be equals to the length of BC, and let that be equals to a variable y. Now we can clearly see that the triangle AOP at the top is a right angle triangle. Therefore by applying the Pythagoras theorem, the length of OA would be equals to square root of 9 plus x square. Okay. Now similarly the right angle triangle at the bottom, that is OQB, that is present over there. Now by applying the Pythagoras theorem in this triangle, the length of OB would be equals to square root of 4 plus x square. Okay. Now as per this diagram, the complete length of AB would become square root of 9 plus x square plus square root of 4 plus x square. As per this diagram, the length of AB is this thing. Now look carefully, the given data was AB equals to AC. Now as per this diagram, the length of AC would be equals to 3 plus y, and that would be equals to AB. So finally we will get this thing, that is square root of 9 plus x square plus square root of 4 plus x square would be equals to 3 plus y. And subtracting 3 on both of the side will give us the value of y, that would be equals to square root of 9 plus x square plus square root of 4 plus y square minus 3. Okay. Now what I can see that is y equals to square root of this plus square root of that minus 3. And the square roots are going to be utilized many times. So what I will do is I will simply substitute them. So square root of 9 plus x square, I will take it as a variable a, and square root of 4 plus x square, I will take it as a variable b. So as per this substitution, the value of y will now turn out to be a plus b minus 3. Okay. Now look in this main diagram, and from this main diagram take out the triangle ABC. So triangle ABC. Now there is a line segment CO, and because of this line segment, the angle C is getting bisected as alpha and alpha. Now as per the diagram, the distance of AO is equals to square root of 9 plus x square, and that has now become A. The distance of OB is square root of 4 plus x square, and that has now become B. Okay. Now what can you say about the distance of AC? So carefully look that the distance of AB has now become A plus B. Therefore, as per the given data, AB is equals to AC. Hence the length of AC will also become A plus B. The distance of BC, that is the base, is 2 plus y. The value of y we have got is A plus B minus 3. Therefore 2 plus A plus B minus 3, that will ultimately give us A plus B minus 1. Okay, let me just remove this thing from here. Now carefully observe the diagram. We have the triangle ABC, CO being the angle bisector for angle C. So if you remember the angle bisector theorem, it states that if there is a triangle and that there is an angle bisector and the sides are marked as A, B, C and D, then ratio of A upon B would be equals to ratio of D upon C. This is the angle bisector theorem, and if you want to see the proof of this one, the link is in the description. So using the same theorem over here, C is the angle bisector, therefore ratio of this upon this, so A plus B minus 1 upon B would be equals to ratio of this upon that is a plus b upon a. Now to simplify this thing further, we can do the cross multiplication. So we will get a square plus ab minus a equals to ab plus b square. ab and ab got cancelled out. We finally get a square minus a equals to b square. Now recall that the value of a is equals to square root of 9 plus x square and the value of b is square root of 4 plus x square. So substituting that over here, so square root of 9 plus x square, the complete square, that is a square minus a, therefore square root of 9 plus x square as it is, equals to b square, that is square root of 4 plus x square, the complete square. Square root and the square got cancelled out in these two terms, so finally we get 9 plus x square minus square root of 9 plus x square equals to 4 plus x square. X square and x square got cancelled out, and simplifying this thing will give me 5 equals to square root of 9 plus x square. We can simply square both of the sides, so we will get 25 equals to 9 plus x square. Subtracting 9 on both of the sides will give us x square equals to 16. Taking square root on both of the sides will finally give us the value of x, that is positive 4. And that's the answer that we were looking for. Okay, so here we have seen the method number 1 to get the value of x, that is the radius of the circle. What we did is we used the Pythagoras theorem and then we did this substitution. If you want you can do, if you don't you do not, that's not a matter. And then we used the angle bisector theorem, and using this all we got the value of x, that is 4. Now let us see the method number 2. So we'll take the same diagram. So now what I will do is I will simply take the angle ABC as a variable theta, okay, and as the length of AB equals to AC, the value of this angle would also be equals to theta. Now by angle sum property in the triangle ABC, we will get the value of angle A as equals to 180 degree minus 2 times theta, okay. Now look carefully in this bottom right angle triangle, that is the triangle OQB that is present over here. So in this triangle the value of tangent of theta would be equals to x upon 2, okay. Now take the triangle AOP, that is the right angle triangle at the top. So in that triangle the value of tangent of 180 degree minus 2 theta, and this thing can be simply written as negative tangent of 2 theta would be equals to x upon 3. So negative 1 on that side, we will finally get the value of tangent of 2 theta, that is negative x upon 3, okay. Now recall the identity that tangent of A plus B is equals to tangent of A plus tangent of B divided by 1 minus tangent of A tangent of B. So in this thing, if we replace A equals to B equals to theta, what we get is tangent of 2 theta equals to tangent of theta plus tangent of theta, that is 2 times tangent of theta, and in the denominator 1 minus tangent theta, that is 1 minus tangent square theta. So we'll use the same identity over here. Therefore in the left hand side, tangent of 2 theta negative x upon 3 equals to 2 times tangent of theta, therefore 2 times x upon 2 upon 1 minus x upon 2 the complete square, that is x square upon 4. Simplifying the right hand side will finally give me 4 times x upon 4 minus x square. Now from both of the side we can cancel out the x, so we will finally get negative 1 upon 3 is equals to 4 upon 4 minus x square. Doing the cross multiplication will give me x square minus 4 equals to 12. Finally we will get x square equals to 16, and this will give us the value of x is equals to positive 4, and that's the answer that we were looking for. So now you can see that by the method number 2 also we got the same value of x, that is 4, and this is an obvious thing because both of these methods were correct. One of them was a geometrical method and this one that we just did is a trigonometrical method, whichever you like. So this was my way to solve this particular question. If you have any other method other than these two, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment you can email me, or else you can send it to me on my Instagram. The link is in the description.